So this is a state of equilibrium. In fact, this is the distance of equilibrium at which r equal to r0, where the potential energy is minimum. Then I can ask you that what is the force versus r graph. Then again, remember, in equilibrium, force acting is always zero, and all of you are familiar that force is nothing but it is the negative of the derivative of potential energy with respect to. Now I would like to differentiate this potential energy function with respect to r, and that is a upon r to the power 12 minus b upon r to the power 6 must be equal to 0. Now I differentiate it. It is minus 12 a r to the power minus 13 minus 6 b r to the power minus 7. You are familiar with this type of, and let f is 0 when r equals to r0. Then, dear students, minus 12a plus 6b, this is r to the power minus 7, this is r to the power minus 13. So if I take r to the power minus 13 as common, then it will be r0 to the power 6, r0 to the power minus 13 will be 0, and that will give me a simple relation: 6b r0 6 equals to 12a, that r0 will be equal to 12a upon 6b to the power half 1 by 6, or r0 will be equal to 2a upon b to the power 1 by 6. Now if I put this value in this potential energy function here, you will find that, so u minimum comes out to be a upon 2a upon b to the power 2 minus b upon 2a upon b to the power 1, and surprisingly this will be minus b square upon 4a. So I can say here, in this case, the minimum potential energy here is minus b upon 4a, and force, of course, at this particular distance is 0. I would like to tell you, and the graph which I can plot is like this. See the graph of force, and we can learn a lot about. This is my main ambition, to tell you that what physics we can learn from this graph. See, this is r and this is r0. It means when you are bringing two atoms closer than r0, the force will become repulsive, net force. And if you take the atoms away from a distance more than r0, then what will happen? The force will become of attraction nature. It means this force not only opposes a rather closeness of the atoms, it also opposes a rather distant nature of the atoms. Mean this force will always try, it becomes a you can say restoring force in both the cases. So that's why all materials are having a property of elasticity, because when you start deforming the object, the intermolecular force, what will it will do? It will try to bring the body or bring the metal back into its original shape. So this is what I wanted to tell you. So I hope you have, this is a very simple way to understand the concept of elasticity as well, which we shall have in future in this particular subject. So today I finish with this particular example. Tomorrow I shall give an idea about the different crystal structures about which we shall deal. Thank you.